this one. See the first heading, I'm talking about your conduction. Can anyone tell me what is the conduction, beta? The transfer of the heat from one point to another point without actual transfer of your molecules. Okay. So for this one, medium is required. First point, medium is required for heat transfer. That point you need to remember. Okay. And there is no actual transfer of molecules. No actual transfer of molecules. Like see if you take a rod and keep it in the, what do you call that one? Fire. That rod will get heated up that part first, then it will transfer that energy to the next molecule, and that molecule will transfer the energy to the next molecule. Like that, the total energy has been transferred from one point to another point. But the molecule will remain there itself, but energy has been transferred from one point to another point, and metal medium has been required for this one. Okay? Am I clear? That is about your conduction. Now, if I'm talking about convection, convection ante generally how beta? When we go for the taking of a bath, we generally heat the water. So when we are heating the water, when we keep a heater in a water, the lower part of the water will get heated up, then it will try to come up, and then upper part of the water will try to go down. There is an actual movement of the particles in this one. Okay, and here also I can say that material medium, point number one, material medium is required. Okay, and number two, there is motion of particle in this one. There is motion of your particle or molecules from one place to another. Okay, the best example for this one is natural convection. Sea breeze, land breeze, that all comes in this one bit. So for natural convection, gravity plays a very important role bit. Gravity plus of your density difference. There will be your natural convection. Land breeze, that all are because of what beta? Convection process. Am I clear? So what is the difference between conduction and as well as of your convection? In the conduction, medium is required for the transfer of the particle. Here also metal medium is required. But in the second point right now here, no actual transfer of the molecule is there. Whereas in convection, the molecule of the motion is happening from one place to another point. Convection, the best example is right now for me, natural convection like sand breeze, land breeze, and here gravity and energy difference plays an important role. Am I clear? The last one is about your radiation. Next one is about your radiation. In the radiation, there is no need of a metal medium because the light which is coming from the sun is traveling the different layers, vacuum, the different stratosphere, ionosphere, different layers of your atmosphere, and it is entering onto the surface of the earth. So I can say that for radiation, there is no need of material medium, no need of your material medium. It can transfer from one point to another point in the form of radiations. Okay, and it is flowing in the form of what beta? Electromagnetic waves. Heat flows in the form of what? Electromagnetic waves. Heat flows as electromagnetic waves. Am I clear with this one? Am I clear? So let us try to first go with your conduction. Okay, like say this is your fixed point, and in between this one, we are keeping a rod like this. Okay, and the length of this rod is like say for example L. Okay, this is at your higher temperature, this is at your lower temperature. That means I'm heating from this end beta. I'm giving a heat from this one. I'm keeping some extra fire here, and I'm heating this part of it with a candle or something like. Now heat has been transferred from one point to another point. Each and every part of this area will completely get heated up, and it will transfer the energy for the next particle length. So heat transfer has been happening from your higher end to lower end. And the metal is having a constant called as of your conductivity, coefficient of your conductivity. So heat is flowing from one point to another point because of what beta? Temperature difference. Same like of your current. How do you define the current? Can anyone tell me beta? Current is equals to potential difference divided by resistance. Did you remember it? That is higher potential minus lower potential divided by R. The same way, what is the value of R beta? Can anyone tell me here? R is equals to rho into L divided by A in current electricity. Am I clear? Or that is equals to your how much for me? L divided by sigma into your A. What is sigma? Sigma is nothing but for me electrical conductivity. Gurtunda? Am I clear? In current electricity, current is being given by the formula. Ohm's law, V is equals to IR. Delta V divided by R. Delta V is higher potential minus lower potential. Resistance of the wire is given by R is equals to rho into L divided by A. Reciprocal of your rho is nothing but sigma. 1 by sigma is known as of your rho. Sigma is known as what? Electrical conductivity. The same way here heat is being flowing because of what? H is equals to difference of your temperature divided by your heat means what beta? H is nothing but heat flowing per your unit time. Okay. H is nothing but what? Rate of heat flow, you write. Anything divided by time is known as what beta? Rate of heat flow. H wins. That means H is equal to what? dQ by dt. dQ by dt is nothing but what here? Temperature difference divided by thermal resistance. That is nothing but equal to your RTH. Okay. So delta T is right now for me what beta? Higher temperature minus lower temperature. RTH is nothing but what for me beta? Thermal resistance. It is known as what? Thermal resistance. You are going to go to the thermal resistance formula. Thermal resistance is equals to L divided by K into A. I'm comparing it better. Am I clear? Am I clear? What do you mean by K? K is known as thermal conductivity. K is known as what? Thermal conductivity. I'm just telling you the nectar, whichever is required better right now. Am I clear? Have you got a clarity in this one? That means I can write here heat flow as what beta? dQ divided by dt is equals to temperature difference delta theta and randi, like delta T and randi. It is L divided by K into A. That is nothing but K into A into temperature difference. So final temperature minus initial temperature divided by length L. Or else Q will be taken as heat flow will be equal to your K into A into temperature difference into time T divided by length L. It's a good cross question. So these are the different forms in which the rate of heat flow is being written. H means what beta? dQ by dt. dQ by dt will be equal to how much beta? Temperature difference divided by thermal resistance. Dini delta theta ani kuda raskochana. That is nothing but final temperature minus initial temperature. One in the same. And very important is here thermal resistance. R is equals to L divided by K into A. K is nothing but what? Thermal conductivity. Heat flow is equals to delta T divided by delta H. So ultimately, this is the formula which you need to remember in the thermal conductivity. Initially, if you're lucky good, you may directly get a question based on this form. Am I clear? Am I clear?
Yes, sir.
Sure. The next one is we'll talk about your temperature difference. Nothing but of your junction temperature. Junction temperature. That means temperature somewhere at your point of your junction. Okay. Like say for example, CF, I'm just giving you a question. If there is a rod which is being connected between these two fixed one. Okay. And I'm giving here the temperature 80 degrees Celsius and here is 20 degrees Celsius. Am I clear? Am I clear? See here.
Yes.
I'm checking junction here right now. Okay. That is a junction. And here at this one, I need the temperature. Say for example, length of this part is L. And thermal conductivity is 2K. Thermal conductivity of this one is K. And length of this one is say for example, L by 2. Okay, so two rods are there beta. This is rod 1 and this is your rod 2. So when two rods are being attached at the junction, what is the junction at which we are attaching the temperature? Now tell me, for this rod, the resistance will be equal to R1 beta, and for this rod, the resistance will be your R2. So what is the resistance? Can you tell me beta? R1 will be equal to R1 is equal. So what is the formula for the thermal resistance? R is equal to how much? What is the formula beta? R is equal to L divided by K. So first one is length L divided by thermal conductivity is 2K into area is nothing but A. Isn't it? Then R2, I'm giving this name as of your R0. Then R2 is equals to, length will be equal to L by 2. Thermal conductivity is K and area is A. So this one will be L divided by 2K into A. This is also same. That is also R1. Now resistance, both of them are same beta. R1 and R2 are same. And heat is flowing from your 80 to 20. In which combination it is? Series combination. There is no division of your heat. That means first rod can be assumed as a one resistor and another rod can be assumed as another resistor. This is at 20 degrees Celsius and this is your 80 degrees Celsius. This is the resistance R1. This is the resistance R2. At the point of junction, the temperature is theta. Am I clear? Am I clear? Done, beta?
Yes, sir.
Now, whatever heat is been flowing in the first rod, the same heat will be flowing in the second rod. Can I say like that?
Yes.
Isn't it? That means heat in the first rod, dq by dt. I'm giving a name. See, this is A, this is B, and this is C. Of your AB will be equal to dq by dt of your BC. Isn't it? dq by dt means what? Better temperature difference. That is nothing but delta theta means what? 80 minus theta divided by resistance of that one is how much for me? Or not? Isn't it? So this will be equal to your how much here? Theta minus 20 divided by R naught. Am I clear? Am I clear? Adamainda? Whatever is
Yes, sir.
heat flowing in the first rod, the same heat is flowing in the second rod. So R naught and R naught will get cancelled. 80 minus theta is equals to theta minus 20. Isn't it? All theta terms you take on one side. Minus theta will go that side and this minus 20 will come here. So it is 80 plus 20 is equals to theta plus theta. This will be 2 theta. This is 100. 100 is equals to 2 theta. Theta is equals to 100 divided by 2. That will be equal to how much for me? 50 degrees Celsius. Got an idea? Got an idea?
Yes, sir.
To calculate the junction temperature when two rods are being connected whose thermal conductivities are different and length are also different for me. Am I clear? Sure. Let us try to do one more question fastly. Let's say for example, I'm having a rod here, right? Roughly. Say for example, this is having a length L and this is having also length L. Thermal conductivity is 2K. This one is of your K. Here the temperature is 120 degrees Celsius. And here the temperature is, say for example, some 40 degrees Celsius. Okay. Now tell me at this junction, what is the temperature? Junction temperature is equal to how much? Faster. Again, which combination better? Series combination. So first calculate the resistance of this rod, R1. Resistance of this rod, R2. So R1 is equals to, it is length is right now L divided by thermal conductivity 2K into area of cross section is right now for me A. So this will be equal to your R0 divided by 2. The same way R2. R2 is equals to L divided by thermal conductivity is K into your A. This will be equal to how much for me? R0 because L by Ka I am taking it as of your R0. Now, can I write this one as with a resistor beta? There is one resistor here like this. Comparing with the resistor, this is another. At last the temperature is 40. Initial the temperature is 120. This is the resistance R1. This is the resistance R2. This is the junction temperature theta. Again series combination. Again I'm giving the name A, B and C. So dq divided by dt of your AB will be equal to dq by dt of your BC. Isn't it? Or simply I can write that was the heat of your AB will be equal to your H of your BC. H is nothing but rate of heat flow. So how do you write this one better? Temperature difference now. It is right now for me delta T divided by R1 is equals to delta T of your BC. This is your AB divided by R2. Isn't it? So delta temperature means 120 minus theta divided by R0 divided by 2 is equals to theta minus 40 divided by R0. Am I clear? So this will go up. So it is your 2 into 120 minus theta divided by R0 is equals to theta minus 40 divided by R0. R0 and R0 is getting cancelled. 2 into 120 is how much beta? Make it fast. 2 into 120 is how much? Array?
40.
How much?
240.
Why 340? 2 into 120 is how much?
240.
2 theta. Two into theta. 2 theta. That is equals to theta minus of your 40. Got it? Then all theta terms on one side. So it is 240 plus of your 40 is equals to theta plus 2 theta. 240 plus 40 is how much for me? 280. That is equals to 3 theta. So theta will be equal to 280 divided by 3. So it is how much beta? 3 nines are 27, 27, 28, 2, 20. This 3 3 is 9, 33.3 degrees only. Got it? Got it beta?
Yes, sir.
Am I clear? Got it? So in the current junction, what is the formula for the heat conductivity beta? Delta Q by delta T is equals to delta H divided by thermal resistance. Thermal resistance is L divided by K into your A. Junction temperature, you got an idea how to do the problem. Am I clear? One more problem. Make it fast. Like say for example, if I'm having 3 rods like this, one rod is here, one rod is here, and one rod is here. Okay, this is your junction temperature. Okay, this is your theta where all the terms are meeting. Here the temperature is 120 degrees. Here the temperature is 20 degrees Celsius. And here the temperature is 60 degrees Celsius. Clear? This is a rod 1. This is your rod 2. This is your rod 3. And given data still are right now for me. This is your length L, thermal conductivity K, area is A. This one is rod 2, length is 2L, thermal conductivity is 2K, area is A. And for the third rod, thermal conductivity is 4K, area is A by 2, length is right now for me L. Okay, now I need to calculate junction temperature. What is the junction temperature? Question is, junction temperature is how much? Junction temperature, theta is equals to how much? Can anyone do it, beta? First you calculate the R1, R2 and R3, beta. First you calculate the value of here. This is rod having resistance of R1. This is rod is having resistance of R2. This rod is having resistance of R3. Now tell me the value of R1. R1 is equals to, what is the formula beta? L divided by K into your A. But I'm taking it as of your R0. What is the value of R2? R2 is length is 2L divided by 2K into area is A. So this value will become how much? 2 and 2 will get cancelled, R0. Then R3. R3 will be equal to how much beta? R3 is equals to thermal conductivity. Length is right now for me again L divided by thermal conductivity 4K into area is nothing but A by 2. 2 ones are 2 twos are. So this value will become how much for me? R0 divided by 2. So if I compare this one with your resistors at the junction, we are getting one resistor like this, one resistor like this, and one resistor like this. So heat is been flowing from higher temperature. This is 120 degrees Celsius. This is your 20 degrees Celsius. This is your 60 degrees Celsius. Resistance of this one is R0 by 2. This resistance is R0. This resistance is R0. When resistance is same beta, the current will be like now. Say for example, I don't know from where the current is been going. What I'll do is I'll take the current from the junction. Okay, and I'll say that current in the going in the first junction is I1. From the junction it is I2. And from the junction 2, this one is I3. And you know the sum of all the three currents must be equal to how much beta? 0. So it is I1 plus I2 plus I3 will be equal to 0. Now tell me for I1, higher temperature, it is going from this one to this one. Na? So at the junction, the temperature is how much? Theta. So it is theta minus 120 divided by resistance is R0 plus theta minus of your 20 divided by R0 plus 2 into this will be equal to theta minus of your 60 divided by R0 because it's R0 by 2 no, so that will go up. That is the reason I'm taking the 2 up. That will become for me 0. isn't it? So this R naught, if it is going on the right side, is everything will become for me 0. So this value will become for me theta minus 120. This is a plus theta minus of 20 plus this is a 2 theta minus of your 120 is equals to 0. Am I clear? All the thetas you take on one side, beta.
Voice pull from Airtel on SIM SIM1.
So tell me, all the thetas you take on one side, beta. So if I'm taking all the thetas on one side, what will be the answer? Can you tell me? Theta plus T2 theta, that will be equal to 4 theta. 4 theta will be equal to minus 120, minus 120, 240, minus 62, minus of your 260. So minus, if it is going other, it will become for me plus. So it will be 260. So theta will be equal to 260 divided by 4. That will be equal to 120 divided 130 divided by 2. That will be equal to 65 degrees Celsius. That will be the answer. Clear? I got an idea how to do the problem.
Yes, sir.
ఇబ్బంది అవుతుంది ఏమన్నా సింపులే కదా. If you sit for 1 hour, you can do the problem. If there is a problem directly based on formula, you should not in a position to miss them. Am I clear? I'm still giving you everything in detail with the help of your numericals. Just need to do the PYQs on this one by keeping 1 hour of an extra time with you. I hope you got an idea how to do the problems of the thermal conductivity junction. Okay. Chalo. Next combination. Series combination. When rods are connected in series, okay, one upon other, like say for example, there is one rod here, another rod here, another rod here, another rod here, another rod here, all of them are same up to n rods. So thermal conductivity of this one is K1, this one is K1, this is K2, this is K3, this is K4, this is K5, so on up to Kn. Length is L1, L2, L3, L4, L5 up to Ln. And area is right now for me same beta for all of them. Okay, so heat will be flowing from your higher temperature. This is theta 1. This one is right now for me theta 2. Or you see theta higher and this is theta lower. Okay, for this one K equivalent, how do you calculate beta? K equivalent, I'm writing the formula directly. First you take all the lengths L1 plus L2 plus L3 plus N is the N divided by Ln. Then simply divided by L1 divided by K1 plus L2 divided by K2 plus L3 divided by K3 plus so on up to Ln divided by Kn. Can you remember this one like this? K equivalent is equals to total length divided by L1 divided by K1 plus L2 divided by K2, go on if area of cross section is same. Clear? And next one is parallel combination. Next one is your parallel combination. Am I going fast, huh? Beta? If the rods are one above the other like this, like that, n number of rods are there like this. I'm roughly drawing better, don't take it serious. This one is A1, this one is A2, this one is A3, this one is A4, this one is A5, this is up your AN. Length will be same better for all of them. The length of this one is right now for me same length L. Okay, so in that case, K equivalent will be equal to directly. Length is right now for me L is equals to same. Okay, so K equivalent is equals to K1 A1 plus K2 A2 plus so on up to Kn An divided by total area A1 plus A2 plus so on up to An. చేసుకుంటారు కదా K equivalent ఇప్పుడు. Isn't easy or not? Done. అర్థమైందా? K equivalent if they are connected in series combination. K equivalent if they are connected in your parallel combination. గుర్తుంటుందా? Done beta? మాట్లాడాలరా?
Yes.
Problem చేస్తారా? Will you do one problem based on this one? Write this problem. Find the equivalent conductivity, that is nothing but K equivalent. Okay, this is a given diagram. Okay, this is the first rod. Thermal conductivity K, length is L. The another one is here. Thermal conductivity is 2K, length is 4L. Thermal conductivity is K and length is right now for me 3L. Tell me K equivalent first. Which combination it is? Side by side. Series combination. So K equivalent in series. And first I told you to add all the lengths. So it is L plus 4L plus 3L divided by L divided by K plus 4L divided by 2K plus 3L divided by K. Okay. So this will be equal to how much better? K equivalent is equals to 4 plus 3, 8L divided by, this value will be equal to how much better? If I take an LCM for this one, this one is right now for me 2K. So here it will be 2L, it will be equal to 4L, plus here it will be equal to 6L. Common. Which in the LCM same అయిపోయింది, isn't it?
4.3.
Yeah, so 2 will go up, 4, 8 2 is 16. So it is 16 into your KL divided by, this value will be equal to how much better? 12L. LL gets cancelled. So it is 16 divided by 2. Okay. 4 3 is 4 4 is. So it is your 4K divided by 3 will be the answer. That's it. Achinda,
Yes, sir.
so question I am giving for you. You try to do it. I'll wait it because my phone in my laptop charging is also over. Just roughly giving, just do that one and give me the answer. Then I'll come back to you. This one is 3A, length is L, thermal conductivity is 2K. This area is L, length is L, thermal conductivity is 2K. Tell me what type of combination it is. Find K equivalent. Chappan Tandar, what type of combination it is? They are one above the other, Gada. One above the other
Parallel.
combination, parallel combination. In parallel combination, how do you calculate thermal conductivity? K1 A1 plus K2 A2 plus so on up to divided by A1 A2. That's it. Come on, do it. Jasepra,
2K.
very good.
2K, sir.
Very good. That's it. K equivalent is equals to what is the formula? K1 A1 plus K2 A2 divided by A1 plus A2. K1 is how much for me? 2K. A1 is how much for me? 3A plus K2 is how much for me? 2K. A2 is nothing but equal to your A divided by A1 plus this is 3A plus A. So this will be equal to how much better? 3 2 is 6 times of your A plus 2 times of KA divided by 4A. That's it. Which in the 6 plus 2, 8 KA divided by 4A. A and A gets cancelled. 4 ones are 4 twos are. So it is 2K will be the answer. That's it. చేసుకుంటారు కదా డన్ బేటా
Yes, sir.
good job. Next one. Next topic is radiation. కన్వెక్షన్ మీరు ఎన్సీఆర్టీ తీసి నేచురల్ అండ్ సి ప్లీజ్ అవన్నీ చదవండి, అర్థమైతే ఫైన్, అదర్వైజ్ ఐల్ హెల్ప్ యూ అవుట్. రేడియేషన్ ఏమేమి నేర్చుకోవాలన్నా, ఫస్ట్ థింగ్ యూ నీడ్ టు రిమెంబర్ ఈస్ రివర్స్డ్ థియరీ ఆఫ్ హీట్ ఎక్స్చేంజ్. Reversed theory of your heat exchange. Sri Chaitanya Narayan Gouda 2018 batch beta, Mr. Varun, All India 6th rank. He was personally my taught student for the physics in that year. 2018, I used to take all the first year class and second year class along with the Aparo sir. And he has completed his PG from the JIPMER. Today he is one of the leading doctor. And in 2018, he was an All India 6th rank from the Narayan Gouda batch. Reverse theory of heat exchange. What do you mean by previous theory? Chapala. As a biology student, you should also have an idea. Simple language. Everybody will radiate energy, but about 0 Kelvin. Like pen, your mobile, your board, your table, your book, your body, your clothes, your specs. Everything will emit the radiations. Am I clear? About what temperature? About 0 Kelvin. All the bodies radiates radiation at all possible temperatures. Possible temperature above what? Above 0 Kelvin. Am I clear, beta? Sure. The next one is about your Kirchhoff law. Kirchhoff's law. Detail go with the Chana on the theory, but I'm not touching that one. So Kirchhoff law says that good observers are good emitters. అంటే మంచిగా అర్థమైతే మంచిగా రిప్రొడ్యూస్ చేసి సీడ్ తెచ్చుకుంటాం. దట్ ఈస్ యువర్ కిర్చాఫ్ లా. లేకపోతే అబ్జర్వ్ చేసి రిప్రొడ్యూస్ చేయలేకపోతే దట్ ఈస్ నాట్ ఏ కిర్చాఫ్ లా. That means emissivity is equals to absorptivity. That's what the Kirchhoff law says. E is nothing but what for me? Emissivity of your body. ఎంత ఎంత emissive చేస్తుంది. A means your absorptivity of your body. Am I clear? And the value of this one is in generally 0 lesser than E is equal to A is lesser than or equal to 1. This is the range you need to remember. Okay. For black body, can anyone tell me what is the values? Black body is a perfect observer and perfect reflector. So E and A is equals to 1 for this one. And for gray body, for your gray body, it is 0 lesser than E is equals to A, and A is lesser than equal to 1. These are the values you need to remember. For black body, E is equals to 1. Whereas for gray body, it is in the range of 0 to 1. Done? The next one is black colored body. Black colored body. What is a black colored body, beta? Black color will observe all the radiations in the visible range. I can say just a minute. Body that absorbs all the radiations, all the radiations in visible range, in your visible range. Visible range ante VGR. Okay, that is your black colored body. Okay, next one. What is a black body, beta? Okay. Okay. Can you tell me what is a black body? Black colored body is different, black body is different, beta. Body that absorbs entire electromagnetic spectrum is called as a pure black body. Okay. A very important formula in this one is Stephen's law. Newton's laws of cooling is excluded, better. Don't do that one. Stephen's law says that very important formula. Number one, heat radiated by the body. Heat radiated by a body is given by the formula dq divided by dt. Dq by dt is nothing but what, beta? Power. That is nothing but P. So here dq by dt is equals to your sigma into A into temperature of the body to the power of 4. That means power is equals to, I can write as sigma A TB to the power of 4. What is sigma? Sigma is known as your Stephen's constant. Number two, heat absorbed. Heat absorbed by surrounding. Heat absorbed by the surrounding will be equal to A sigma capital A temperature of surrounding to the power of 4. Okay, that is the formula in which you need to remember. Okay, I'll just write the terminologies of that one here. A is known as absorptivity. Okay, E is known as emissivity. Okay, sigma is your Stephen's constant. Value గుర్తుందా ఎవరికన్నా? What is the value? 1 2 3 వచ్చా మీకు? 1 2 3 4 4 తర్వాత ఏమొస్తుంది? 5 5 తర్వాత 6 6 తర్వాత 7 7 తర్వాత 8. So it will be 5.6 5.67 into 10 power minus 8. 5 6 7 8 గుర్తుపెట్టుకోండి. 5.67 into 10 power minus 8. A is your surface area. TB is your temperature of body. TS is your temperature of surrounding. Clear? Sure. Now this one is very important below. Net rate of heat loss must be equal to how much it is emitted minus how much it is absorbed. This will give me the rate of heat loss. అంతే కదా, isn't it? That means d cube divided by dt is equals to E sigma A TB to the power of 4 minus A sigma into A TS to the power of 4, isn't it? If emissivity is equals to absorptivity, this is equation number 2, this is equation number 1. So then d cube divided by dt will be equal to how much for you? E sigma into capital A, temperature of the body to the power of 4 minus temperature of surrounding to the power of 4. This will be the answer. Very important formula, Stephen-Boltzmann's law. We call this one as of your Stephen-Boltzmann's law. Okay. Then beta, last one very important formula. Then we'll try to do some problems. And today 10 o'clock we'll try to do this paper beta which I sent you. Please try to do that. Wings displacement law. Now see, after this class, just within 5 minutes you can revise complete heat transfer beta. Okay. What is the wings displacement law beta? The wavelength corresponding to the maximum emission of any radiation decreases with your temperature. Just remember the formula. Lambda m charging okay. Lambda maximum wavelength is inversely proportional to temperature. Clear? That means maximum wavelength into temperature is equals to some constant. The constant is represented by your B. And the value of the B is 2.89 into 10 to the power of minus 3 meter Kelvin. Okay. And dimensions of the B what examination lab. What are the dimensions of your B? Dimensions of the B is M0 L1 T power 0. Very important. There is no temperature also. T temperature to the power of 1 in terms of Kelvin. Done. Then this graph also you need to remember. This is y-axis, this is x-axis. On y-axis we take intensity, on x-axis we take the wavelength. Okay. As wavelength has been increasing, it will become maximum to 1 point, then it will become minimum. So this will be at some temperature. At a wavelength of lambda 1, temperature is right now for me T1. As you increase the temperature wavelength, what is happening? Temperature will be decreasing. It will try to shift in the front direction. This will be your temperature and this will be the wavelength in lambda 2. See what is happening as wavelength is increasing, temperature is decreasing. Clear? So these are the some of the basic formulas which you need to remember for doing the numericals. Clear beta? In the time revise hardly it will try to take for 10 minutes and try to do the last year's PYQ questions. 5 years if we take the papers, you'll get top idea. Okay? We'll try to do some problems at 10 o'clock class before we start the paper. Okkasari just go through this complete notes. Revision అయిపోయిందా? అవి చదివిన వాళ్ళకైతే ఈజీ, చదవని వాళ్ళకి కొంచెం టైం పడుతుంది. You take another half an hour and try to revise it better. You can easily do that one. Done beta? Sure. Take care. Bye and come at 10 o'clock by doing some problems on your side. And before that, I just need everyone how many questions or you are in a position to do. That question numbers, I need them with your name. Just take a photo and send in the WhatsApp group to me. Okay, na? Sure. Bye.